right, this is the 12 p.m. Zoom meeting on Thursday, October 29th. It's the day of the hurricane. I think all the campuses, UNG campuses, are closed today, but we'll hold the Zoom meeting. If anybody wants to join us, welcome to. Otherwise, I'm just going to work some problems from section 3.7. So if anybody wants to come and watch the recording later, see how things are, some of these problems are worked, that's fine. So this is 3.7 this week. Remember test 3, Friday, 15 questions, true or false, 6 points each. And I will add 10 points, your Google form score. All right, so again, it covers 3.1, 2, 3, 4, 5, 6, and 7. And you were mailed out a review sheet last night. Emailed review sheet last night. Yeah, I got it a little late. Apologize for that. All right, let's start on page 352. Say it, problem 5. Solve x plus 5 squared, x plus 3, x minus 1, strictly greater than 0. Okay, don't let this square throw you. This is a multiplicity 2, which means you have x equals -5. That's a touching x-intercept on the graph, whereas x equals -3, x equals 1 are crossing x-intercepts. All right, we will lay it out. -5, -3, +1. Notice no or equal to. Open circles. These numbers are not answers. Stick them in, you get exactly 0, which is not greater than 0. Open circles on this one. All right, and we just got to figure out which of these intervals will give you a result greater than 0. Start with -6, say. -6, add 5 squared, x plus 3. I'm sorry, -6 plus 3, -6 minus 1. Now you see what the square does here. Yes, inside you're negative, but squaring turns that positive. This is negative, and this is negative. Greater than 0? Yes. The two negatives here with that positive are going to be positive and greater than 0. Yeah, you're in here. Without the square, you wouldn't be. With the squares, turns it positive. All right, try -4. So x equals -4. This was x equal -6. Okay, so we've got -4. Add 5 squared. In fact, this first piece is going to be always positive. You see how this inside's positive and squaring is positive? This first piece is always positive. You got -4 add 3, and you got -4 minus 1. Oh, we have a participant. Glad I looked up and saw. Would you like to identify yourself? I can't see your name.
Yeah, it's Lucas.
I'm sorry, can you say it louder?
Yeah, it's Lucas, sorry.
Oh,
I
Mr.
think the
Clark.
microphone's really quiet on this thing.
Okay, no problem. Did you have any questions or problems you wanted to see?
Not really. It still makes sense, but I'm just here to watch it, especially since we have the test tomorrow. I want to get as much review as I can, you know?
Okay. Well, I'll finish this one and then ask if you want to see anything. I'm just doing number 5 off of 3.7 here. It's got
Awesome.
four intervals to check.
Yeah,
So
totally.
yeah, so probably you got the whole page there. You can kind of see what I'm doing here. But yeah, I'm checking this interval for -4. So yeah, this first piece with that square is always going to be positive, whether you're sticking in a negative or positive number, because the squaring is turning it positive. You're still negative there, and you're still negative there, greater than 0, and that works. Yeah,
Perfect.
yeah, you're working there, you're working there, yes. All right, I guess we use 0 here. That gives us 0 add 5 squared, 0 add 3, and 0 minus 1. Greater than 0. Well, that's positive, 0 plus 3 positive, but this one will be negative. That's 1 negative. So overall, you're negative. Greater than 0, no. So this one is out. And then if I try 2, we have 2 plus 5 squared, 2 plus 3, and 2 plus 1. And greater than 0, and you can see, yeah, it does work. Positive there, positive, positive, greater than 0, yes. So copying down, barely enough room to write the answer. Negative infinity, comma -5, -5, -3, and then jump over 1, comma infinity. 3 of those intervals work. Probably without the square, only 2 of them would work, but the squaring is putting 3 of them working in play. All right, well, that's the first kind of problem in this section, is basically a polynomial out, and they were kind to you because they factored it. Further on, you get more, and you're going to have to factor them and collect terms, a lot of algebra to start it. And in the last section for this, you have these fractions, and particularly down here, toward the bottom of it, it gets pretty nasty. Is there anything in particular you want to see, Mr. Clark?
Not really. I'll just be here for the ride.
Okay, do you want to see one where you have to factor?
Sure.
Okay, let's see. How about 15? Or sorry, 13?
Awesome. Sounds good.
Okay. This is probably going to be more of a project. May be here a while. Yeah, I appreciate you coming out with all the storm and everything. I think I saw an email that all the campuses are closed.
Yeah, there were a lot of power outages. My neighborhood's one of the few around here that didn't get hit, but I mean, we got like storm and stuff, but it wasn't that bad around here.
Yeah. Well, luckily my power stayed on, so yeah, I figured I'd go ahead and do the session, and then yeah, anybody who wants to yeah, watch it later if it helps them, because we do have the test this week.
Yeah, totally.
Yeah. Ordinarily with 4 pieces, you want to think grouping, but I hope you can kind of look in your crystal ball and realize it just isn't going to work. If you pull out your x squared, you're left with x plus 1. Stick an x plus 1 over here. All right, you need a minus 17x, and you're going to get a minus 17. Just this grouping here with 4, it just wasn't cooked to group. That's going to make this a bit of a project, because to factor this, we are going to have to find a 0. To factor this, we must find zeros. So we need our list of all possible zeros. This will be a good review of earlier sections. This one they've made. So we're going to have to resort to our list of all possible zeros. You remember they call that P over Q, and it's factors of 15 over factors of the lead number, which is 1. Well, dividing by 1 isn't going to change anything. So it's really just the factors of 15. plus minus 1, 3, plus minus 5, and plus minus 15. So it's going to work. I'll write the plus minus 1, but really, you just have those top numbers, and we're going to hope one of those is a fact. It should be. This is one of those is a 0. So if you remember how this works, we need x to the third plus x squared minus 17x and plus 15. And we will go to table set. No, we're on app. Good thing I did. Okay, so we're going to go to auto, hit enter. Finally go to table. And it came up 10 on, and you can see just getting bigger and bigger. We're not going to get anything that way. So back up the list. We're getting smaller and smaller. Hopefully we're down to 80. Nirvana, x equals 3. Zeros. X equals 3. Are we lucky enough to have any more? Yes, x equals 1. And that's all we're, oh, no. Negative 5. Oh, they gave us all 3. This is nice. Remember, it should have 3 zeros. All right, and yeah, there's only 3, yeah, so I don't have to mess around with it anymore. There's our 3 zeros. So this factors to x minus 3, x minus 1, x add 5. Didn't really, I guess you don't technically have to write the factored form down, as long as you know your zeros. We will put negative 5 first, and then 1, and then 3. We have an or equal to, so this one will have closed circles. Or equal to, closed circles. And now it's just a matter of checking in between. Okay, I technically didn't have to write the factored form, but if I don't, then I got to check them all up here, which is a bit more of a pit of punching numbers. I got 4 numbers to punch in these intervals. And yeah, I theoretically could punch them up here without this, but can you see how, this makes it nice?
Yeah.
So we'll check x equal negative 6. Negative 6 minus 3, negative 6 minus 1, and negative 6 add 5. Is that greater than or equal to 0? I hope you can tell it isn't. Negative, 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 greater than or equal to 0? No. Odd number of negatives, it's negative, so that's not greater than or equal to 0. So we're out. I guess we'll use 0 in here. 0 minus 3, 0 minus 1, and 0 add 5, greater than or equal to 0. Are you getting quick enough to be able to tell that, yes, this works? Because that's negative and that's negative. There's 2 negatives. This is positive.
Yeah.
Yep. That works.
So it's just like find all possible zeros. They're specified by the original, like greater than or equal to 0.
Yeah. Now, if they really wanted, they were really kind to us, believe it or not, because they gave us all 3. Gave us a formula or polynomial with all 3 integer zeros. If they'd only given us 2, I'd have to set up the factored form and probably do a long division to get what the third and divide this into that to get the third 0. That's when it really becomes a project. But they're kind to us. I don't guess we'll thank them all at once.
Yeah.
All right, so x equals 2. So let's see, we got 2 minus 3, 2 minus 1, 2 plus 5. All right, that's negative, and we got 2 positives. So this is a no. 1 negative is still negative. On the other side of 4, you probably can tell that's going to work because you got 4 minus 3, 4 minus 1, 4 add 5. Yeah, they're all positive. Yes. Answer then. Going to be between -5 and 1, but with brackets because you are including, because the -5 makes this 0 and 0 is greater than or equal to 0. So yes, you're including -5 and 1, and you're including 3 and going off to infinity. Questions about that?
No, it makes a lot of sense actually.
Okay. Well, that's examples of problems that are polynomials, straight polynomials, and then the new sort of version, and I work some of these Monday night, is these fractions. And it's basically the same thing. You want to take, you want a 0 on one side, which they give you up until like right here. If notice down here, they don't. And so you get, well, they do right here in 31, but on the ones that don't, you're going to have to do some algebra to collect to a fraction and get a 0. So they look like these. You need your zeros at the top, zeros at the bottom. That's what's going to divide your intervals. You spread those out and you test between those. You in the mood to see one of these?
Sure.
An easy one up from up here or a nasty one from down here?
I'll say easy one. Make it easier on you.
Okay. 19?
Sure.
Okay. Solve. 2x plus 5. X squared plus 2x minus 35 greater than or equal to 0. Hope you recognize the pattern on bottom. If you recognize the pattern, we should factor it. Plus 2x plus 5, and let's see, x and x. I think it's plus 7 minus 5. X squared minus 5, add 7, be positive 2, and minus 35, yeah. So we made this point Monday night. I don't know if you got a chance to watch the Monday night video. Very important to keep track of where your zeros come from, top or bottom. Top, zeros. You must find zeros, top and bottom. Find zeros, top and bottom. That would come from 2x plus 5 greater than or, I'm sorry, you want it straight equals 0. You're trying to find the exact number that makes this 0. So 2x equals -5 and x is -5/2. Okay, that comes from the top. Okay, bottom, zeros. So that's x plus 5, x plus 7. X minus 5 equals 0, which means x is -7 and positive 5. These are from the bottom. Spread this out. -7 come first. -5/2, -2.5. That's -2.5 or 2.5 would then come before 5. You want to put on your circles. This is where it gets technical. Do you understand that if a 0 comes from the bottom, it will always be open?
Yes.
Because they cannot be answers. They're making you divide by 0 here.
Yeah.
Okay. So bottom zeros are always open circles. Open circles. The top circles, these are bottom. This is bottom. You don't have to obviously label all this when you're working the problem. I'm trying to do it for teaching purposes. This is from the top. Now you understand that the top is going to depend on the or equal to or not.
Yeah.
Therefore, this will be closed on this problem because of the or equal to. Take off the or equal and you'd be open just like the others.
Awesome.
Okay. So you really, on these fractions, you really got to watch for that. This is very technical. See, that's going to leave the parentheses here and brackets here. That's
Okay.
very technical. Are we ready to, from this point on, it's identical. You just test in between. But we're going to test in this entire fraction. Are we ready to test?
Yeah.
Okay, so I guess we'll try -8. We'll have 2 times -8 add 5. -8 add 7. -8 minus 5 greater than or equal to 0. So it's a matter of working out these signs and divide, figure out overall what the sign is. You can clear -16 add 5. That's a negative on top. There's a negative there. -8 add 7 is a negative. -8 minus 5. That's a negative. I got 3 negatives. You can argue as positive on bottom, but negative divided by positive, or you can cancel out one of the. I mean, you can argue it however you want, but bottom line, 3 negatives. This is going to be negative, and it doesn't work. Questions about that?
No, it makes sense so far.
Okay. All right, between -7, -2.5, maybe we'll use -6. So we got 2 times -6 add 5. -6 add 7. -6 minus 5 greater than or equal to 0. -12 add 5, that'd be, it's going to be a negative top. This piece is positive. -6 add 7 will be positive. And that'll be negative. -6 minus 5 will be negative. So there's 2 negatives. With this positive, that's an even number of negatives. This is positive. Yes. We're in. I guess we use 0 here. We got 2 times 0 add 5. 0 add 7. 0 minus 5. Can you tell this is not going to work?
Yeah.
We've got 1 negative. Yeah, they discharged at 10 p.m. last night. No, they're demanding to see a cardiologist. They said there's nothing to do for it. I'm sorry, back to it. Positive here, negative here. This is not going to work.
Awesome. Because, yeah, with 2 positives and 1 negative, it would be a negative.
Right.
Awesome.
Yeah, finally 6, you probably can tell is going to work. After a while, I don't know if you're ready to, I'm writing all this stuff down for teaching purposes, but you probably can tell by this time, 2 times 6 is 12, add 5, that's positive. 6 add 7 is positive. 6 minus 5 is positive.
Yeah.
Yeah, so all positives work.
Perfect.
So answer. Parentheses -7, comma, -5 halves, bracket. And parentheses 5, comma, infinity.
Awesome. Could I check the zeros by just plugging the thing into the calculator and just looking at where it hits the line?
Okay.
Does that make sense? Did I?
If you wanted to, that is another way to do these. You could.
Yeah, it's just like usually when I work it out, I go check it just to make sure,
Yeah, if you want to see what you would have to plug this in and say, look, are you looking at a graph?
Yeah.
Yeah. Now we've already plugged it in. It's already plugged in. Window. Yeah. So if you look at a graph of it, you can, if you wanted to mess around, but you can tell it comes up here and curls back.
Yeah.
Okay, so there's your -7. Your -5 halves would be this one. No, I'm sorry. No. Wait a minute. I didn't enter this one, did I? I'm entering the other, my fault. I never entered. I'm doing the other formula. No wonder things didn't. Okay, my apologies. All right,
No, it's
parentheses,
okay.
2x plus 5 divided by, and then parentheses, x squared plus 2x and minus 35. Okay, graph. Okay, so there it's blown up at the -7. That's a vertical asymptote. It's got a vertical, okay, it's kind of coming through. Okay, the -2.5 would be right there. You can't hardly see that on the graph. There's your x-intercept at -2.5. And then it's finally blowing up at 5. So yeah, what you're looking for, greater than or equal to 0, this is above the x-axis. So you can tell this side of -7, you're below the x-axis.
Yeah.
So you're above between -7 and to the -2.5, and that's where you need your bracket. Then you go below, so that's not in, and you finally come back above from 5 to infinity. If you can read that, help yourself.
Yeah, that makes sense.
Okay.
Perfect. Thank you.
But yeah, it is hard to read it all off the go, like the -2.5. That'd be really hard to read off.
Yeah,
the go.
totally. You'd have to have it written down and just use that to check.
Right. That's why by hand analysis really, does kind of help. Let's see. We're 27 minutes. Have you got the patience for one more, or
Sure.
you want a tougher one with some algebra?
Yeah, totally.
Well, let's see. 33.
Awesome.
Okay. We'll be here a while. So on page 352. 6 over x minus 1 over x greater than or equal to 1. All right. Gonna be some setup algebra here. Over x minus 1 minus 6 over x minus 1 greater than or equal to 0. We've got to collect into one fraction. Three of them, it's a little more involved.
Awesome.
The denominator will be the x minus 1 with an x. Okay, I'm going to just kind of collect it, x minus 1 with an x.
Perfect.
Okay. You just got to kind of imagine, you got your 6 here. You just got to kind of imagine what you would do to go from this back to this. All right, now you see you already have the x minus 1.
Yeah.
All you need is an x.
Awesome.
Okay, on the next, you still have a minus 6. You already have an x. You need the x minus 1. So you can imagine if you cancel that, you'd be back to minus 6 over x. Here, if you cancel the x, you'd be back to your 6 over x minus 1.
Yeah.
Okay. Now, when you do the 1, that means you're going to need both of them. Minus x minus 1 with x. So that all of this over all of this is minus 1.
Awesome.
Okay, it's now just a matter of combining terms. And you got a 6x minus 6x adds 6. And minus x squared with a positive x. On the bottom, you still have your x minus 1 with an x greater than or equal to 0.
From here on out, is it just the same as the last one?
That what now?
I said from here on out, is it just the same as the last problem?
Well, basically, but you want to keep boiling this down.
Yeah.
looks like you're getting a negative x squared, an x, and a 6. You want to see if you technically don't have to factor it with a minus x squared. You could use the quadratic formula to find out what your zeros are, but you're going to need your zeros to then spread. From the bottom, your zeros are 1 from there and 0 itself. And yeah, it's going to be another page. Finish this page and probably another page. If you've seen it and everything, don't feel obligated to stay around. I'm probably going to finish it just for completeness for anybody who wants to view this later. So, but don't feel obligated to hang around.
Awesome.
So yeah, if you're going to need to leave, no problem, and I appreciate you coming out.
Perfect. Yeah. I'll probably head over and eat lunch because I'm kind of hungry. But thank you.
Sure thing. No problem at all.
Yeah. See you later.
We'll see you. Okay, so yeah, the 6x's are going to cancel there, and you're going to wind up with negative x squared, add x, and add 6. And x minus 1 with an x. This is going to be a little tougher factoring. If you put a negative out front, you might see it better, but let's see if we can play around with it. How about a negative x and add 3 and x add 2 maybe? Over x minus 1 with an x. Negative x squared. I think I hit it. Negative x squared, you get a negative 2x, plus 3x is 1x, and a plus 6. Okay. Otherwise, you could have used the quadratic formula if you didn't want to mess around with it. Top zeros. Negative x add 3 equals 0, negative x equals negative 3, x equals 3, and x equals negative 2. Bottom zeros. X equals 1 and 0 itself. Open circles. Closed circles. You're equal to. Put this in order. Negative 2 come first. Then 0, then 1, then 3. Bottom, 1 and 0, open circles. 3 is closed, negative 2 is closed. Just a bit of a pain to check through this, negative 3. And we're checking in add 3 plus 2 over x minus 1 and x. We want it greater than or equal to 0. All right, so x equals negative 3. You're getting negative a negative 3, add 3. Negative 3, add 2. Minus 1 and negative 3. All right, this is a positive there, this positive, negative, negative. Yeah, negative 3 itself is negative. That's 3 negatives. No. Yeah, 3 negatives. All right, negative 1. Negative, negative 1. Negative 1 add 2. Minus 1 and negative 1. Greater than or equal to 0. This is 1 plus 2. That's positive, positive, negative, negative. That's 2 negatives. Yes. Oops, my lights just flickered. I don't know if I'm going to finish this or not. A half. 0 and 1. So x is a half. Negative a half, add 3. A half, add 2. A half minus 1. And a half. Positive, positive. This is negative. This is positive. That's 1 negative. No. Lost that light flicker